Okay, so far you may have agreed with me that choosing a good hash function is crucial to the performance of a hash table. So if we have a bad hash function and then it put all the possible keys into the single slot, and then what is going to happen? So no matter what key we have, this hash function always send the new value to the same slot, and then on this slot we are going to have a lot of collisions, right? So this is a bad behavior. And on the opposite, a good hash function should distribute the keys uniformly into the slots, and it should not depend on the patterns of the data. So this is an ideal hash function. So we are going to discuss three methods: the division, the multiplication, and then the universal hashing. So for the division, and this is probably the easiest, right? So we take a key, and that is the key k as the new key, and then we just do a mode m. So why do we mode m? Because m is the number of the slots possible in the hash table, right? So we take an integer k and then we mode an m, and we guarantee to have a value between 0 and m minus 1. So let's come back to this example. So we know in this hash table we only have 10 slots, and then I'm sorry, it should really be, oops, come on. Okay, give me 1 second, let me erase it. Okay, so we have 10 slots, so the indexes should really be 0 to 9. Oops. Okay, here we go. We should have 0 to 9 in this case. Okay, so if we have a value, say 17, and where do we send this value to in the hash table? If we want to use the 17, and I'm sorry, well, the keys in the hash table is only from 0 to 9, so we have to do a 17 mode 10. And why it is 10? Because 10 is the number of the slots available in this hash table, and then we got a 7. This means the 17 should go here. Okay, and then if we have a 56, we mode a 10 again, so we got a 6. So this means 56 should be here. Okay, so this is the easiest hash function. We just take whatever key we have, and then we mode by the number of the slots possible in this hash table, that is m. So we guaranteed to have the new key to be, so the hash function, the key to be a value between 0 and m minus 1. So I'm using square brackets because both 1 and m minus 1 are included in this range. Okay, so oops. That is a division method. So, well, if we are dealing with adjacent keys hashed to the different slots, and then, well, that is a very good case. For example, we send 1 and then it goes to slot 1. We send 2, it goes to slot 2. We send 3, it goes to slot 3. So if we are dealing with adjacent keys, and then that is a perfect hashing function. Well, but if the keys bear relation to m, and then that is bad. So what do I mean here? So if we send 60, so 60 mode a 10 will give me a 0, and then we send 70. So 70 is the next key, and then 70 will give you a 0 again, and 80 another 0, and then 90 another 0. Oh boy. So now we have the problem because all the values are going to slot 0. So on the slot 0, we are going to have a lot of collisions. So in this case, probably it's not a good idea to use that one. Okay, so to reduce the possible number of the collisions, if we want to use the division method, and usually we want to pick the table size m to be a prime number, and that prime number is not too close to a power of 2 or 10. So usually this is the golden standard to make the division method usable. And the next one. So the next one is called multiplication. So for this multiplication, well, we have to pick a constant a, and this a is between 0 and 1. Okay? And then for a key k, we are doing the m multiplied by this part. For this part is the ka minus the integer part of the ka. So k multiplied by a and minus the integer part of the k multiplied by a. So in this case, in this parenthesis, we have the fractional part of the ka. So this fractional part of the ka is guaranteed to be between 0 and 1. So we multiply by m, and then we take the integer part again. So this value is again guaranteed to be between 0 and m minus 1. So those are the allowed keys in the hash table. So usually we want to choose a m to be 2 powers something, and then we choose an a not too close to 1 or 0. So well, in one of the research paper, this person suggests that square bracket is the square root of 5 minus 1 and then divided by 2 is a good value of the a. So that is another solution that is called multiplication method. So I will see you in the next video. In the next video, we'll talk about universal